So guys, we move in sequence. To the next one is the work example. But before we talk about this work example, we quickly look at the position vector of one point with respect to another point. So doing that directly, I'm going to take one side of this slide to explain that very quickly. Now, talking about position vector of one side with respect to the other side, we are going to take our coordinate system as usual, which we have x, y, and z plane. And for that, I'm going to have a diagram, not actually drawn to scale, but it will be a good one. So now we have x axis, y axis, and as well as the z axis, which is always in this format, as you can see. So we are taking position vector with respect to what unit vector from one point. Now, position vector we've talked about as is just what the vector of a particular what of a particular point with respect to the reference point, which is always the source of origin. So taking that directly, my dear student, we are taking the first vector. I'll take that one from the origin position vector. I'll call it position vector to point P. I'm taking that one like this. My diagram may not be drawn to scale, but you are going to manage that. That's the first point, dear student. We're taking this P. And the position vector from source of origin, remember, we call RP vector. All these are just for understanding's sake. We take the second one. The second one, which is, I'm taking another vector from this same point. I'll call that one to point Q. So I'm taking it, then I'm having something like this. We've done this before if you watch the video in series. So I'm calling that point of that particular vector, I'm going to use Q. So the position from the point of origin, I'm going to call it RQ vector. This. Then I'm joining the two lines together as usual, which will be the position vector from point Q to point P. I'm going to call P to Q, which we call RQP. We've talked about this all along in this series of vector explanation. So position of vector of the two lines joining this one from P to Q, we call permit me, guys, RQP. RQP. So keep that at the back of your mind. And what I want to bring out here is to understand some concepts. So at this point P, I'm taking the coordinate system is XY plane, after written as 2, 4, and 5. Remember, in form of standard unit vector. I'm taking Q at this point Q. The point Q is having a coordinate system of 4, 1, and 2. Then the question is, we should represent this and find the coordinate of what? Of the third one. That is what we are looking for. Because we know for P, we know for Q, then we should know for what? RQP. That is the third part. So what I want to explain here is just, let's first of all represent this in coordinate system from what I've in standard unit form, which we have explained. So we can say the position vector of RP in unit vector form will be 2i, remember that, plus 4j cap, I cap, j cap, plus 5k cap. And the position vector of q vector from here will be rq, will be equals to, we are doing that with respect to standard unit vector, that is 4i cap, I hope students are following, that's xyz plane, plus j cap, then we have plus 2k cap. So that is that about that. Then to get the third one, which is what we need there, we can use our knowledge of triangular vector to solve this, looking at the direction and getting what we need to know. Now we can say, without wasting time, from this analysis and the direction of that triangle, that therefore, we can just write in sequence that RQ vector is equal to the sum of RP vector, this particular vector, plus RQP vector, or position vector of that, anyhow you want to write it. I'm just using my triangular vector, which I believe you understand. What I'm saying is this and this is being balanced by this. So RQ vector is RP. Look at their direction. This is going up. I think that will be better. This is coming down. and this is balancing the 2. So, or you can do it in another way. If you want to take this as 2 of your magnitude and you are coming by this, you know it to be negative of a vector. I hope you still remember negative of a vector that we've talked about. So we can say, we can make the third one, which we are looking for, RQP vector is now equals to RP vector minus RQ vector. So keep that in mind, which is very, very important. So doing that, all what we just need to do here is just to subtract the P vector from the Q vector. And if we do that directly, we can always say the answer to this is nothing but, please be careful about what I have done here, because you need to be careful very well, because I'm looking at the direction to actually know what to subtract. So be careful. I am subtracting RP vector from RQ vector. And if I do that, the answer I'm going to have here is that 2i minus 4i. 2i minus 4i is nothing but, I'm just doing direct subtraction, guys. I'm going to have negative 2i cap. Then 4i minus 4j cap minus j cap. This one is 1. I'm going to have 4 minus this. Sorry, guys. I'm doing, it should have been from my subject of formula, it should have been RQ. I will have screwed that minus RP. So because, please, I hope you guys can see the mathematics aspect of this. So what should I have there? Should have been, I'm subtracting this from this. 4 minus 2. 4 minus 2 is nothing but, that is 2i cap. Then here, j cap minus 4 cap. That is negative 3j cap. Then the last one, 2 minus 5, is also negative 3k cap. So that will be the value of the answer of position vector of what we call RQP. So directly, that is the answer for this. And if you're asked to find the magnitude of that, which we write as magnitude, which is always in modulo form, as you can see, of RQP, will now be equals to the square root, I've explained that in the last slide, of 2 square minus you have plus negative 3 square, which everybody knows the square of a negative number is always going to give you a positive number, and another negative 3 square. Doing this mathematically, I know students can actually get answer to this. We are going to have something like 4 plus 9 plus 9. So doing that, you can always tell the answer under the comment section, which will be what you all can do. This 9 plus 9 are 18, 18 plus 4 are 23. So square root of 23 will be the answer to that according to my explanation. What I've done now is just explaining the position vector of one point with respect to the other point. So always keep that in mind because of other examples. And now we face what we have here. Now a quick one, my dear student, because of time, we have a car in the northeast direction at 10 meters per second takes a turn towards the east and maintains the same speed. The question asks, we should find the change in velocity of the car. So I think we need to draw the diagram to understand this. Now, still using our vector understanding and component of vector to solve this question. Solution we can write, it is moving in the northeast direction. I hope students remember what we call northeast direction. It can move in the north direction, not northeast, please. North direction. It's moving in the north direction and not northeast. So permit me to make it clear. I think that's typo, just like we have typo here. North direction. So if it is moving in north direction, direction of north is always to this side. So and it's moving with a velocity of 10 meters per second. So we take that one as the first speed or velocity, as the case may be. It's 10 meters per second. So we are told that it takes a turn towards the east. Everybody knows the direction of east. East side is always towards this direction. And that's the second velocity. I'm going to take that as second velocity. I'm going to write as V2 velocity. Now, without any further delay, you can see this is just what we have talked about in negative of a vector. It goes without saying. Now, this is towards the x-axis, as you can see. The first one is towards the y-axis if you're going to use your coordinate. I hope you understand this. Now, directly we can say the first one is moving like this one is what? In this direction, we can say, we can write it in mathematical form of representation of vector by saying the first one is having V1, which is the magnitude of 10, and direction of what? 90 degrees. The question is, where is my 90 degree coming from? It is because this is a straight line, and the straight line is called perpendicular line. So direction. And the second one is now having, look at V2, the same what? The same magnitude of 10, but direction is now parallel. We write direction of parallel as what is 0 degree. You can write it meters per second if you like, meters per second. I hope you understand this. Now, the question is, we are to calculate the change in velocity. Now, even without any further delay, students should know something. The direction of the first one is not the same thing as the second one, but we are told that they maintain the same speed. The meaning of this is that maintaining the same speed means both the V1 and the V2, they are having the same magnitude, but this one is in what? Negative what of a vector, which we've discussed. So the change in velocity of the car, we have to just draw a good diagram again to explain that very well. And doing that, dear students, you are going to have something like this. Now, we have the second one. The first one is moving in this direction. I have 2 minutes more to end this. Then the second one is moving in this direction. Or let me just start like this. It's moving like this. As the V2. Then we are looking for the change in velocity of the car, would be the resultant of this, which will be from the point of this. Look at this. I'll use arrow for understanding's sake. This is going to be the direction of the second one, which I'm taking as negative or vector, because it is of the same magnitude, as you can see, but what? In opposite direction. And this one is or for me to understand, because I want to move here, let me make V2 the one moving in X direction, and V1 I will change its direction, so that we understand better. This is the X direction of V2. Then the V1 is having the same magnitude of 10, but the direction is not the same. I'll take it as negative V1. I think it's better in this one for understanding's sake. Then looking for their change in velocity, I'm going to join this point to this point. This, we have from here to here. Anyhow you want to do it, you have this and you have this. It's a very simple question, but to understand direction of vector, that is what I'm going to do. This one is moving like this. Now I am changing this direction that is moving up to down. That is why I'm changing the direction of what? Of my sign here, from 10 to negative 10. So what I'm going to have here is negative of vector. You can see it's going up. Now if it is coming down, just for explanation's sake, is going to be negative 10 as negative of a vector, so that I can have a good diagram. This is moving like this. This is moving like this. Then this is what? The balance point. So now I can do this directly by using my Pythagoras theorem, which everybody knows. This is 10. This is also 10. Then going by that, this will be 10 root 2 if you are very good. So change in velocity will just be, you don't need to waste your time. Just do directly. You can say 10 squared, square root over 10 squared plus 10 squared. So directly you can use your third form. This will give you nothing but 10 root 2 meters per second. You can also be asked to find out the direction. The direction now in which this thing is now moving is now in the direction of, this is the cardinal point for those who don't know. North, south, west, and east. So the direction in which this thing is moving, if you bring this here, you can just put your north, your south, your west, and your east. You can see the direction of the resultant. It lies between the southeast, because this is my resultant, which is this going like this coming like this. Then we add them together and going by the result. So I hope you understand this. See you soon. That is where I will stop here. Bye for now.